15. Track B. Hope, Hype, Horrors. E-commerce explored.
Can you take it outside the talk, please? Thanks. Today I'm going to be talking to you a bit about e-commerce and security. I titled the talk Hype, Hope, Help Needed. A lot of the ideas and the information in this talk is based upon my experience working as a researcher and talking to a number of other researchers who work in this area. I talk a little bit about some of the issues of building e-commerce applications, but mostly it's about research issues. I must tell you as well that this talk is being recorded, and I will repeat your questions so that they can be captured by the recorder. So some definitions and caveats. Electronic commerce, as you can read, is a secure exchange of goods, services, and information electronically. It's from Forrester Research. Now, Forrester Research and a lot of others build a lot of hype in this as well, so that it's bound to boom. And the reason for that, of course, mainly is because the success of companies that build e-commerce sites, and then all of a sudden their stock prices go up, irrespective of the number of sales that they make. And the case in point, of course, is the famous bookstore, the online bookstore that we all know about, no names mentioned. So this talk will not be an e-commerce course. It gives a research perspective. I talk about some of the vulnerabilities, and especially some of the wireless vulnerabilities that have not been reported. And I give some of the highlights in the research perspective. So I'll talk to you a little bit about e-commerce today, some of the problems that are builders of e-commerce sites face, and the future of e-commerce, especially from the research perspective. And but I'll be talking only about a few challenges. But if you look at the list at the bottom, there are quite a few that are there, and I'll give a few conclusions. Now, what is said in this famous Dilbert strip about e-commerce is also true for researchers trying to get funding. In fact, I gave a talk somewhat along this line in Taiwan. I had this slide translated into Chinese, and I changed it so that the little character with the great hairstyle is a researcher looking for funding, and of course added a few more words, including things like Java, agents, artificial intelligence, all those things are hot. So there's a lot of internet hype. In the business consumer area, of course, the idea is to try to lower costs. You don't have to have the salespeople because you have an online store. As we all know, it really doesn't work out that well. You have to advertise. You have to advertise in print media, and you have to make sure that your site gets the traffic that it needs. So you have to use all sorts of other means to garner the traffic. There's a real market expansion, but you know, frankly, I think it's going to go bust because of the whole issue of the availability of information. And it's so easy now, for instance, for a merchant to put all of his goods online, and then someone can use a simple bot that can go around and find the best price. And you're always in competition trying to pare down your costs so that you can beat the latest, lowest price. And I think it's going to come to a point where people are going to realize that only the lean, mean corporations can really afford that kind of business. In the business-to-business area, there's a huge amount of growth. I'm going to go a little bit over the hype. And a big part of it is the low cost of telecommunications, so everyone can be online, and the cost of internet access is way low. For instance, in the UK, internet access is generally for free now. The growth has been phenomenal compared to the deployment of other technologies such as radio and the TV and the PC. As you can see, that turquoise line is really steep. And figures for the growth overall are way over the map. as ranging to a high of over $300 billion for business to business in 2001-2002 timeframe. So right now, e-commerce really works very well. There have been a few problems with implementations, but basically you have the same sort of common threats that you find in all sorts of other applications. So I'm going to go over a few of those. Around 1995, SET was introduced, and SET is kind of a disaster area. Merchants wanted to get their products online, and really the way that most people do it now is using secure sockets layer for interchange of credit card information. That's certainly in North America. In Europe, it's a different story where SET has played a bigger role. The problem that people have in building e-commerce sites is that there's so many different products to choose from to do so. There are many different credit card transaction providers, as well as different servers and software products for providing the security for the e-commerce site, different databases, and different web portals, and of course many consultants who provide all sorts of advice on the topic. The trouble here is that with each of these different products, and services, first of all, you have different APIs, for instance, so that as a developer you have this real challenge of trying to build something that's going to meet the needs of all sorts of different clients. You end up having to reinvent the wheel all the time. As well as that, you have the problem of different vulnerabilities that show up in the different products, and this ranges down from the operating system all the way up to the actual applications. So the common threats today, and this is probably all well known by people here, range from insider fraud, which is the key one, and as we've all heard, the figure of 85% of all threats today come from that area, and software security holes, and some of them are just implementation errors. That's really the main problem, and those really come at all layers. So denial of service vulnerability in an application or an operating system affects the whole. It can affect your whole storefront, and either as a provider of a transaction service or a provider of the information on your website, you don't want those things to happen. But then you get things like simple setup errors, which the software itself can be really quite secure and protect the information in behind on your server, but if it's not set up properly, as you may have heard of some of the recent storefront vulnerabilities having to do with gaining access to credit card information, it's really because of setup errors. Some of the threats to buyers are hijacking and or spoofing a website, denial of service attacks, loss of privacy, loss of your information, and fraudulent credit card use. And the threat to sellers, well, they don't want people to get really tired of waiting for a transaction to happen. And so any sort of denial of service or a fake order flood would do that sort of thing. It would keep the server really busy and prevent people from really doing bona fide transactions, or slow it down to such an extent that they'll just give up. And site impersonation, this really gets to the point where the reputation of the site can be affected by someone impersonating it, and site alteration would do the same sort of thing. And for financial institutions, the same sort of story. Really, they're looking at their own reputations. They want to be the ones, the people who provide the transactions, for instance, want to be the ones who can garner that little increment, the little bit of money that they can gain for each of the transactions. And so they want to make sure that all of their, they're not vulnerable anyway to any sort of attack. So now I'll really start to focus on some of the future challenges in e-commerce, talking about what is happening in research today, starting with something along the lines of what has happened with some of the standardizations, the area of trust, business-to-business e-commerce, agent-based e-commerce, automation and learning, and copyright protection and electronic distribution, and e-commerce anywhere. So, in research, it's a big competition. All researchers, they have to get published. They want to gain as large a research grant as possible. And what I've seen more and more is that they're really talking about e-commerce. This is what the thing that they want to do, irrespective of their background. And generally, they're not in the security area. They're working in other areas. For instance, they are doing a lot of agent-based research. And I'll talk a little bit about that later. So they don't really think about security. And yet, if you look at their application grants, and I've reviewed a few, they have things like security and electronic commerce, as well as agents and Java, and of course the all-important word ontology, which has to do with the way agents talk to each other. The trouble is that when you give them the money, they sort of go off and do all sorts of little things, and the brew that they mix up is not quite what would be palatable for most online merchants. Some of them are really great ideas. The other side of the issue is that most university researchers now are really focused on becoming more application-oriented, development-oriented, because they realize that industry is going to be providing them with the funding. So what they end up doing is trying to run to where the money is and get on board with the companies as well. The trouble is there are a lot of acronyms in e-commerce, and here are just a few of them. One of the problems here is that in developing all the different standards, it often takes many years, as we've seen with SET, as we've seen with most recently the new push to ECML. There's a lot of industry push in the different directions that have started out these standards, but in reality what happens leads to a lot of confusion. And so what you have are, in the case of researchers, they tend to jump on one of the other bandwagon. And this is a good or a bad thing. By doing so, if you have a lot of them jumping on one particular bandwagon, they can really push that forward and along with industry. And fortunately, with a number of these, this has been a real boon for the business. And ECML is certainly one of them. This is the case where you have some sort of conformity between websites for access to the information that a user might have in an electronic wallet. In the area of trust in electronic commerce, biometry is one of the key areas that's looked at as a way of determining whether the user is actually bona fide to perform a certain transaction. But there's also the whole idea of determining the trustworthy of transaction participants in all sorts of other sites, based on, for instance, how well that person has performed in the past, how well that business has performed in the past in dealing with different types of transaction. So in the area of research, there's the whole idea of distributed trust, being able to provide web browsers with some sort of measure of trust of the user. This gets to be a little bit like Big Brother, sort of monitoring what you're doing. In the case of the research, it's more the idea of having a community of that would determine how well you're performing using a grading system. And of course, the area of agents that would have certain levels of trust depending upon the types of transactions and that they performed at different sites. There are different models of trust and formalisms that are especially used in the agents area. Makes for interesting reading, but it's still pretty primitive right now. In the area of electronic commerce and workgroup applications, there's this other notion as well. A number of companies have developed, for instance, applications for workgroups that would try to do a business process re-engineering sort of thing, where they actually look at how people are interacting on a network and try to determine how well to match people for new projects. So there are all sorts of different technologies that could be used in this area, and I've just listed a few of them here. A real problem here is that really they have to work very well, and right now a lot of the technologies are a little bit need tweaking, shall I say. So you get some false positives and false negatives, and by tweaking you can make it work pretty well most of the time. But even 95 to 99% is not really good enough. But another big problem here is that if you lose your biometric data, and that is if someone, all this data is just something that's stored on your hard disk that might represent some aspect of your biology, it's kind of irreplaceable. And something like an iris scan means that, well, maybe you could use your other eye, or maybe you could use another fingerprint, but if you're using your voice, that's another matter altogether. So if someone was able to gain that information and use it to access a database based using other information that you may have, like a password, then you don't want that to happen. It essentially becomes something like a single sign-on to everything, which is not always a good idea. In the area of some of the standards, SET, of course, was thought to be this wonderful thing that was going to be the answer to all the problems having to deal with electronic transactions. Now, it's great because it prevents this the no card present fault, because that information isn't transferred. And Visa and MasterCard really like that, and that's, of course, why they backed the standard, and eliminates non-repudiation of transactions, and there are no middlemen. But it's a really complicated process, and as we know with SSL, it's really quite a slow, it's computationally very intensive. In this case, you need many more steps to get this thing running. So with 3,000 lines of ASN.1 code and 28-stage transaction process and 6 RSA encryption steps, we're talking about something that really can bog down a server. And the interoperability of the four-part model is also makes it difficult for to work with many different applications. The thing has been constantly through evolution, and now they're talking about things like SmartSet and other possibilities with the use of XML for EDI, and there's been a big move in the standards for XML EDI. In the case of public key infrastructure, to support things like SET, you need a public PKI, but it also supports many other applications like VPNs. It's a cornerstone for network security technology. There's PKI does a number of different things for you in terms of handling your security for your network, but there are some real problems and challenges with it. It's very difficult to set a PKI up. And a PKI up isn't, one PKI being up doesn't mean that you've solved the problem. You have to set up a number of them across different organizations, or if your organization is extended, you then need to worry about cross-certification. A lot of the software is a bit like, it's really very beta-like. Actually, we've used internally Entrust's PKI, and then there are the whole issue of interoperability. And there are at least 2 interoperability labs that I know of that actually test PKIs from different vendors, and they found all sorts of issues around the interoperability of the certificates themselves. Part of that problem has to do with the version 3 extensions and the differences between them all. Some of them are very application dependent, where, for instance, using Outlook and using Netscape and a certificate from one server and not being able to read mail appropriately, even though you're provided with the information. There's certainly a lot of network overhead. This issue comes into play with certificate revocation lists, and depending on how often you poll for those lists are sent out to the clients, it can certainly bog down, say, 100 to a couple of hundred user network over a 10 base T. The costs are another thing. The infrastructure is, once you put the infrastructure in place and you spent all the money on the consultants and the software itself, you need to buy the applications. So Outlook itself, you have to buy a $50 application that will support the certificates. And that goes on and on for other applications where you'd like to have use the PKI certificates. Then there's the whole problem of using multiple certificates. Once you have a PKI infrastructure set up and you want to deal with transactions with different vendors, or you have different companies you want to share email, for instance, you end up having multiple certificates. In these would be the cases where you perhaps don't have a cross-certification arrangement. And that gets to be very difficult and complicated to deal with. In the area of business-to-business e-commerce, the factors here include just-in-time delivery. Businesses want to get products out as quickly as possible, and they want to make sure that their business clients and their subcontractors operate in the same fashion as well. So whenever a new order comes in, they would automatically just pass a subcontract off to another one of their subcontractors to help reduce their own inventory and the cycle times. Supposedly to reduce costs, and it really does work. Business-to-business e-commerce has been very successful that way. This has led to, of course, globalization and deregulation to international trade, a greater degree of international trade, so that you no longer have to look within your own country to have subcontractors. You could look very easily around the world, and with electronic communication, be able to set up transactions and have contracts arranged very quickly. So in the area of developing trust with these new partners, some of the research is looking into how do you arrange trust in the situation where you have three companies that have very similar contractual arrangements between one company. For instance, in this case, company A deals with B and C. Why can't company B deal with C? Or why can't there be a way of automating the process to make it more readily possible for B to deal with C? Because they could be very similar in the way they operate. There's also a problem in trying to figure out how to have low-cost, secure, large transactions. SEP provides that now, but is there another way of doing that through some other means? And so there's been some research looking at that area. There's a shared, and there's the other idea of sharing the minimum required operational information. Most companies are very secretive about what they want to share with others, and so when you're trying to develop trust with your partner, you want to tell them just enough so you can get the job done. So that leads to this other problem of, well, if you want to automate this trust negotiation, how do you do that in a way that maintains the low level of sharing of information? So in agent-based e-commerce, and in this case, there are a number of different options. We all know about things like bargain finder agents, software agents that will actually go out. They're usually sitting on a server, and they'll just query different websites to find out the best price for a product. There are also automated negotiators that are being worked on for business-to-business applications, and user interface agents that would actually try to adapt to the user. And this is more along the lines of trying to streamline the e-commerce site to make sure that for whatever user is at the site, using some information garnered from the way other similar users have accessed the site, to ensure that web pages are presented in a way to keep the customer interested. And then there's the whole idea of trying to use mobile agents in these particular applications. Now, this is really kind of what I feel is a bit of a technology looking for an application, because mobile agents are in many ways kind of scary. There's been a lot of work done in trying to improve the security of mobile agent technology, and most of this work has, of course, been using Java. And Java has a reasonably good security model. There have been some problems with vulnerabilities in the Java virtual machines, and for instance in Netscape Navigator or Netscape Communicator. But for the most part, it's a great idea. Unfortunately, when you come to the point of having agents that move around from machine to machine, and where you have the authentication of the agent and knowing exactly what the agent is doing becomes a major issue, especially if you're operating a server and you offer a place for an agent to come. I'll talk a little bit about that in a second. Actually, right here. So some of the challenges in e-commerce and agent-based e-commerce has to do with the trust of the agent code. And as I mentioned earlier, for most mobile agents based in Java, the code is simply digitally signed. And a digital signature really doesn't say anything about who wrote the code. You know maybe the name of who wrote the code, but you don't know whether that person followed any sort of secure practices in writing the code. You don't really know how secure the code is. You don't really know perhaps exactly what the code does, except by the name of the agent itself. You don't know if it's really part of an agent system or not. There are some people who have looked at trying to do some sort of agent authentication based upon the role of an agent operating an agent system, and trying to make sure that an agent can only operate if it's scheduled to operate at that particular time, and it's fulfilling a certain role, and then it's the access to some of the databases, for instance, or network access to different protocols would be controlled by the role of the agent itself. The other issue here is the confidentiality and integrity of information. In the case of a mobile agent, for instance, some of that data could be transmitted as part of the code itself. Once it's actually as an object within, say, the agent itself. Once that mobile code moves to another machine, it might be available to some other user by simply having a virtual machine that has been altered, so that you can actually examine what is in what code has been downloaded at the time, and actually looking at the structure of objects and figuring out because Java is very nice that way. Using reflection, you actually can find out all sorts of details about the internals of the code that you've just downloaded. Then there's the whole issue of standards, and in the case of agent-based e-commerce, there have been several different moves afoot. Some of the earlier work has to do with knowledge-based, knowledge query markup language, or modeling language, and in this case, most researchers tend to use this model for communicating between agents. It's really a very simple ASCII-based strings that are transferred between agents to interrogate other agents as to what they have to offer. There's been a standards body, FIPA, which has been looking at developing a standard for agent communication, but it really doesn't speak to any sort of level of security for agent communication. You would rely, in this case, on secure sockets layer for communication. Agent environments themselves there must be at least 20 to 30 different environments, perhaps 10 of them from companies who have produced environments that are either for sale or for license. They're all quite different, and they offer very many different levels of security for agent distribution. And of course, the APIs are way over, all the way over the map. In the area of intellectual property protection, the idea here is that it should be easy to distribute intellectual property over the net. You just download it and you have some way of protecting it, hopefully, and the idea is to lower distribution costs and potential risks. But it also could lead to some new forms of licensing. And this diagram gives you an indication of some of the types of licenses that are possible with different types of intellectual property. So with software, it's generally an exclusive license. But that's not to say that it wouldn't be possible if you could have some sort of way of configuring software, depending on the user, that it could be very individual. And so that you'd have a different type of model. In the case of multimedia on demand, you have everything that ranges from something that might be exclusive, that you just would like to have one user use, to something that's free tradable. So you have different models for different types of intellectual property, and you'd like to have different levels of protection that you might like to put on these different pieces of intellectual property. In the area of software, of course, there's a big issue of software copying, and these are just a couple of covers for some CDs that are available commonly in Hong Kong. And in fact, the upper one contains about $45,000 worth of software. This is not my own. I asked a friend to send me a scan of this. Things like Adobe, Photoshop, and Illustrator. And the upper one cost about $6 US. It's a 2 CD set, and the lower one costs about $3. They're readily available. Then there's the whole problem of trying to protect software. Well, in the case of software copying, cracking is epidemic, and you just need to go to the web to find lists of cracks for software that can be downloadable from website. So manufacturers who currently produce software many of them tend to try their own protection methods, and a lot of them are really very poor. There are a few that use some cryptographic techniques that are an improvement, but that's really no guarantee. It's just a lot harder to crack. Hardware dongles, these dongles that attach to parallel ports or serial ports, and other software protections, generally they tend to be things that people really don't want, because you can't easily transfer software to another computer very well. If you upgrade, for instance, you need to get a new key. In the case of dongles, it's not a big issue, just move the dongle over, but that means that if you lose that dongle, tough luck. You're going to have to talk to the manufacturer, who could well be gone by the time you want to do that. So you need some sort of flexible electronic licensing, and some sort of way of protection that it just would discourage copying or trying to crack software. In the area of the recording industry, analog copying is really quite easily done. Many people don't accept that, but there are moves afoot, of course, with new techniques for, trying to embed some sort of means of protecting copies of music CDs. Microsoft and IBM are working on this with Sony and others. But unfortunately, the standard is so far behind. All they have is really a shell of a document that describes some of the rudimentary things that they would like to do, but there's no details as to the protection techniques that would be used inside. E-commerce anywhere is another area where quite a bit of effort has been put into in the area of new developments and in some cases research as well. The idea is to provide wireless access to investors and business operators and service centers. It provides a great deal of convenience for them, and there certainly is a high demand for those types of services. I don't know, has anyone ever heard of v-commerce, voice commerce? This is a technique, actually there's a site where you can try it out, and it uses your voice, and so it uses it's voice-independent speaker recognition, where you train the device to recognize some particular phrase that you give it, and that's used as your password. Unfortunately, I found it very susceptible to false negatives, and this is one of the biometry things that you find with the technology. It's really quite nascent right now. It's just starting out. But more than that, eavesdropping is a real problem. So you can just record someone's voice giving the password, and you've got it. I mean, it's kind of useless. So replay is an issue. As well, when you're looking at using voice telephones, wireless telephones or pagers, trying to provide some sort of secure layer over that is another issue. Wireless LANs, in the case of providing access to users who, through wireless means, and this might be through internet service provision or within a corporate LAN. These are great devices. Does anyone use a wireless LAN now in the audience? No. This is actually what I have on the right is a sketch of a wireless system that we've installed in our building, and you can see from the diagram the coverage of the LAN itself. The line at the bottom is 100 meters, and the coverage goes well beyond the building. It's very hard to control wireless LAN coverage. I mean, you could try to put LED up around different parts of it, but in reality, it's going to get out there. And this is just using the standard antenna. If you use an antenna that's actually focused for a dipole type antenna, you can actually garner a larger coverage than what's shown here. This is a 2 megabit per second system operating at 2.4 gigahertz in the ISM band. Now, this becomes an issue because someone can just be sitting in our parking lot and get into our network. They could also hear other conversations in the network because these devices work in a peer-to-peer or peer-to, in this case, an access point. The access point acts as a bridge between the wireless and the wired world. That's one issue. But another one has to do with the implementation of these wireless LANs. And they use something called the IEEE 802.11 standard for implementing the lower level communication channel. It provides for encryption, but unfortunately all you have to do is open up a window and you can read the encryption key. Once you have the key, I mean, now you can actually go and break into my network very easily if you have one of these cards. It's just a few $100s anyway. Digital Roamabout is the same card that's now being sold by Cabletron, and also it's based upon the Lucent technology. But worse than that, this information is all available using SNMP, and the access point uses an SNMP version 1, which is very very easily broken into. And you can find out the encryption key and all the other settings required to set up your wireless LAN access point or your wireless LAN modem so you can communicate with my access point or overhear conversations with other modems. So in summary, e-commerce is here. It's thriving. It works really very well, and there have been very few problems. There's been a lot of publicity about some of the problems that have happened. Big money is going into the research into e-commerce, both for developers and for the researchers. But whether it's being really well spent is another issue altogether. Partially because some of the standards that are out there now have been forced really because of the market. So the fact that we are really based upon credit card transactions is one of the issues right now. Software implementation errors, we really want to patch those as soon as patches become available and keep that up to date. It would be great to have some sort of way of software-hardware version authentication on devices, on hardware and software, so that you know that when you're performing a transaction that this hardware, for instance, is authorized to do those, that it's actually the software is up to snuff to actually perform the transaction. That's not available right now. In the area of electronic delivery of intellectual property, you'd like to be able to enforce copyright protection in a way that is non-intrusive to the user. You don't want the user having to go through all sorts of gyrations to make sure that they can transfer the software to another machine when they upgrade. In the area of e-commerce everywhere, you have the issue of, well, as I just mentioned, the wireless technology. Similar holes exist in pager technology, for instance, and of course in the use of cellular phones. Using some form of biometry sounds like a great idea, but it has to be really accompanied by some sort of careful thought as to how you protect biometric data in a way that assures that there's no loss of privacy. E-commerce agents, again, another wonderful idea, and some of them work really well right now, especially the ones that operate from servers. But agents that actually move around from point to point are just are just problematic. So there's lots of room for innovation in this whole field, and I provided you with a URL for some links, and there's my email address. Do you have any questions? Yes?
You mentioned SET several times. A year and a half ago, to be very honest, I've heard SET mentioned again in presentations since RSA 98.
That's right.
What's going on with SET? I mean, according to some of the people I've known who are in the industry working on SET, it's dead. You haven't said it's dead, but you haven't said it is.
Well, I haven't said it's dead. The question was what's happening with SET, and that it's about a year and a half ago. You didn't really hear much about it, and I mentioned it in my talk. I mentioned that talk because, again, if you go to the websites for Visa or MasterCard, they talk about how it's renewed, and they're looking at it again, and they're looking at a big implementation. So they're trying to resurrect SET. I agree with you. SET is pretty much dead in the U.S., but certainly if you look at Europe, it's not.
I don't know if you went to RSA 98, but that was, I mean, they were talking about it almost every presentation. You know, we got to get it in. SSL isn't good. You know, SET's got to go. And then you went to RSA 99. Now it was mentioned once, or was never a key component of anybody's presentation.
Mm-hmm. This is again, that's right. This is a big problem with the long turnaround cycle for trying to develop the standard, and then trying to get around some of the problems of the heavy-duty implementation you have to do to get SET going. And I think that I don't think Visa and MasterCard are just going to give up on it. And what is the replacement?
Yeah, but if you remember, it was Visa, MasterCard, American Express, Discover, JCB, and basically every major credit card was involved. And now most of them have pulled out.
Right.
And to be very honest, what I was hearing was Visa, MasterCard were going to try to go out their own way independently of each other. They weren't even going to support any of the standard they'd already put out.
Mm-hmm. Well, I haven't heard that. The question or the response was that there were other card people who were involved in the standard originally, and now it looks like there's some sort of separation between Visa and MasterCard. So certainly that may very well be. It's still a standard that some people, and certainly in Europe, they use quite heavily, and it's something that you really don't want to ignore, especially in terms of some of the standards issues that you could get around when you come to implementing a store site here. I mean, the implementation is a big problem, though, and the speed. Yes?
In your research, the implementation of some of these sets, like set, how prevalent, when you say it's prevalent in Europe, but not prevalent in the U.S., it's almost non-existent here on the commerce sites. But in Europe, how much are you finding it?
The question was how prevalent is SET in Europe as compared to here and U.S. and Canada, because it's not really seen here. And in Europe, certainly for business-to-business e-commerce, it's the thing that they use. And I couldn't give you a figure. I don't have a figure on that. But it is heavily used.
Just a point on the set thing. I wasn't supposed to. Nobody's saying anything about it, but there was with the Microsoft E2000 docs, there was this implementing set for e-commerce on in a 2000 environment. There was a paper.
What, at 99? So I was just had an executive briefing Microsoft 2 weeks ago in San Francisco.
Yeah,
not San Francisco, in Seattle. And then you mentioned it there.
Yeah. I just found it on the web.
Yes.
You mentioned biometrics, which is, in my opinion, still a little bit out there as far as being deployed widely. You did mention, though, where smart cards and other tokens that could store exploding credentials. Can you talk a little bit about that?
Okay. The question was, I mentioned biometrics, but not smart cards, and which can store all sorts of information, a certificate for the user, for instance, that sort of thing. And certainly, some companies are Mondex cards, for instance, which widely available in Europe and widely deployed. I mean, you know about the vulnerability in the Mondex card and that sort of thing. I think that certainly that's another alternative, and it's certainly much better than just trying to jump into biometrics. It doesn't really work. Okay, I'm not sure if that really answers your question.
My question was, it seems that the focus on biometrics is a little bit misplaced, because that's maybe 5-10 years down the road, whereas hardware tokens are storing credentials.
That's right.
Almost here.
Yeah, that's right. Well, hardware tokens really are here, and it's very heavily used in the UK, for instance. And so that's why I didn't really mention it in the area of research. Okay, thank you for that point. Yes?
You know, you see all the hype about electronic commerce and PKI and all this other people are using. Okay. You see all the hype about electronic commerce and PKI and all these other buzzwords, but yet when you're looking at this is really with the internet, it's literally a global architecture, and the operating systems and some, LDAP, we just had a talk in the previous session about that. All of those have to be configured and working right for these upper level applications to have a chance of working, and yet in many of the talks they don't address those, or they're not really focusing on that. It seems to me like these other things are doomed, because if the underlying architecture is flawed, eventually someone's going to break in there, all the confidence is going to get lost, and since it's talking about people's money, they'll withdraw using it. So could you comment on that?
That's exactly right. The whole idea of you rely upon everything, all the way down to the operating system, and you rely upon the platform, the hardware platform. Everything has to be running, and you want to make sure that it doesn't break down, because that's going to affect your visibility on the site and the loss of personal information, all that sort of thing. So that's right. LDAP is just one of the issues, and some of the other ones are the ones I mentioned. That's right. And across different platforms and throughout different technologies, and PKI with that problem as well. Yes, that's a good point.
I'd like to make a point on that same thing, is that people always, people went from 5 years ago where it was absolutely ridiculous to put your credit card information on the net, and then we get SSL, and they say, well, now it's improved. But then you can say, well, the transmission is great now, but now we can get at it through improperly configured operating systems at the other end. We can fix that, but who has it at the other end? And how do we know that they're not making a copy of all that credit card information, putting it on a floppy, and dropping it off at some corner for a bag of money on their way home?
If it has been addressed, credit cards from the beginning, going to restaurants, how do you know the waiter was going to copy over your numbers? You're covered when you use the card for $50, you get $50 you pay. In most cases, a lot of transactions, credit card companies will want to charge you a fee. And if the loss becomes so high that it starts to cost credit card companies some money, then things like SET and other protocols will start to really.
Yeah, I agree with that point.
Time, it's a write-off.
Yeah, I agree with that point. I'm just trying to say that it goes even further than the underlying operating system. It goes right down to public, like policies, human policy.
What's going to have effect is on business-to-business transaction because there is no coverage. If you lose it, it's lost. If $1 million goes down the tubes, you're responsible for it. If I put $1 million in my credit card, hypothetically, and it goes to one place, all responsible tenant, $50.
Could we just take one question from Jesse over there?
One question for you and one comment about the discussion that was just going on there. Question for you, I didn't hear any mention of micropayment schemes and where you see them fitting into this whole research evolution or being as feasible as possible. You know, there's some problems with them theoretically, but we'll talk about that for a moment. And the conversation going on over there about either the insecure operating system or who has it, when they have it. A gentleman in the middle there made a very good point where it becomes a real issue with the business-to-business side of things, where there's no coverage with my credit card company is the internet capital on my side. If someone steals it, well, I have a little bit of a hassle, but I'm effectively covered. This harkens back to something I think it was might have been Rich and I or might have been someone else at last year's DEFCON was talking about, which was you can't ever eliminate any threat on no matter how perfect your OS, how perfect your hardware, how perfect your protocol, and we know we're not going to get those. There's always going to be some threat someone hasn't thought of, there's going to be some problem, but you can manage risk and you can have these systems continue to work if you can quantify the risk and offload it and get insurance or handle it in any number of ways. So my guess is the way we're going to see, similarly we have an insurance industry now for disasters, things like that. You're going to get a lot of this higher end e-commerce stuff going business to business side. There's going to be contractual, legal, you're going to bring actuaries in and they're going to say, if this transaction will fail, we lose $1 billion. Okay, what's our insurance payment for this? And they'll just write it off one month, which will be a really interesting business model to see. Quantize security threats for insurance.
So the question to me was about micropayments, and the other comments was about the whole issue of it's very difficult to assure security on a site to make sure that you don't lose credit card information. In the case of business-to-business e-commerce, you're looking at they need and they want to have contractual arrangements anyway, and they want to be bound by those, and they want to make sure that they use a much more secure transaction protocol than SSL and their arrangements. In the case of micropayments, there certainly was a lot of talk about micropayments some time ago, and some microcash, and there were several other eCash. That's right, quite a few others. And I don't understand why they really take off, because I think they're a great idea. I think that the whole notion of being able to, an interesting business model for being able to pay for a website, for instance, to be able to charge for different things in very small amounts. Certainly the whole notion of how do you keep track of all of these things is another issue that you're well aware of. And I just don't understand what's happened. And I haven't seen much in the way of research in that area. I don't know if anyone else has. Are there any other questions? Yes?
I just have one observation. You
said that you felt that the e-commerce, because of some of these other entity activities of smart technology that will shut down other people, making it so that you actually can't compete because everybody will go to the best source. But currently today, in the financial community, we have online trading that does billions of dollars of transactions every day. And there is competition. You see the ads for the $8 a trade, $6 a trade, $12 a trade. Don't you think that people will be more into the actual experience if it's a tough site, even if it's a cheaper product, but the support isn't there and all the other surrounding things aren't there, that there still be the same level of competition?
Okay, the question was about agents that actually look for bargains, and whether or not in the case of a transaction for stock transactions that people might just either have brand loyalty, or I'm taking words out of your mouth, but also they might use other preferences other than cost to determine whether or not to go to the site. I think that remains to be seen. I think there's a lot of it's going to be driven by cost. Certainly I know that when I'm looking to buy something, I'd look for the lowest price, and I would certainly be willing to put up with an annoying site if I know that I'm getting a really good deal. But the other side of that is whether or not the person I'm doing the transaction, the company I'm doing the transaction with, is reliable. And I would really like to be able to have a measure of how reliable that company is, and not just by using a review of what that company is. Now, eBay, I think, has some sort of way of determining sort of trust of people who perform different transactions for their auctions, and there's some work being done in that area to try to make that more automated. Does that help with your question?
That's pretty much. What I just wanted to point out was that the same thing in a normal town, you have competing businesses on the same street, and there's different prices for a cup of coffee, but you don't find everybody having a cup of coffee at the cheapest one. And in some of the e-commerce models that the company I work for, we've been doing is based on the experience, people's concepts of their brand loyalty, but also the ability for all the other features like support that are built into the product itself. Everybody knows you can go out there and buy a PC for $230, but people don't buy them for their critical system.
Okay, yes, I can make another comment on that. And what you were just saying was about how there are many factors that come into play when you look at brand loyalty. And an interesting study was performed by a Korean researcher for the Japanese reselling market. This is selling used cars. And they found that people were paying on average, very much higher for the cars, even though there was they could buy them more cheaply using other means, but they would go to one particular site because they knew that the car was very reliable. Now, automobile is kind of a different situation than, say, buying a new computer or something like that. But in this particular case, they knew that they could trust that particular reseller to make sure that they would get a car that would last and give them good value, even though they were paying on average something like $1,000 or $2,000 more on a $10,000 transaction. Yeah.
I guess I'm close enough to use that. Just sort of to follow on that, but a question that to me really seems to be big, because again, the big architecture. When IPsec starts to really become real, the level 2 stuff will be sort of resolved, which means host-based security issues will become bigger and bigger. Do you see that electronic commerce and other things might tend to drive to a single type of operating system because in security, it's always when you go between operating systems or between types of application that you lower everything to the lowest common denominator and get rid of all the security to make them work. Do you see any drive to potentially standardize on OSs and particular maybe even directory structures from things, so that the electronic commerce could have this reliability and insurability that we're discussing in here? Do you think that could really be a possibility? I mean, we only have so many manufacturers and certain other things because that cost model drove it to that. Would you like to comment on that?
I think you're right. And I think that those new standards will make a big difference, and that companies will either be forced to move to them because the rest of the world will, or other applications will. And in the case, moving to even to IP version 6, a lot of talk about doing that, but it's a big inertia, and it's similarly with IPsec, a lot of inertia to make that move. And especially if you've just invested a lot of money in your site or in setting up a transaction service, you're going to want to make a transition that keeps your sanity. So it's going to be a tricky process. Yeah.
Any other questions?
Any other questions? Thank you very much. Oh, yes, sorry.
Just a little comment on the statement is it's not, security isn't weakened by interoperability between operating systems, right? Rather say it's a result of misconfiguration and human errors and not using the right tools appropriately. So, I mean, I would say that using the same platform is
Okay.
alternatives.
Yes. Okay, the whole idea, the comment was about heterogeneity doesn't automatically mean lack of security, and certainly I agree with that. I guess the problem becomes when you do have something that's heterogeneous, you have a lot more different things that you have to take care of, make sure that they're operating correctly, and it'd be nice to have a means of automating that to make sure that everyone's up to snuff and they're set up properly as well. Okay, thank you.